So we're going to finish off with concepts and categories. Okay, and let's start off with a few important definitions. So the first being categorization. So when we're categorizing, we're forming groups of items or events based on common features, right? Creating categories. When we're discriminating, it's distinguishing items based on one or more different features. You could discriminate things based on their categories, right? And then another term here, concept formation, is of course establishing the rules for category membership and also updating those rules. So a few important definitions there: categorization, discrimination, and concept formation. Okay. Also give some examples. Might be you see two different chickadees and you know that they're both chickadees. They're in the same category. They belong together. Now discriminating within birds, maybe you would see these two birds as different, a chickadee and a hawk, as being separate from each other. Right. Different categories. And then the idea of concept formation to create a category, maybe for small songbirds, for example. And you might have rules for that membership. So small passerines or songbirds. They're small physically. They have a certain kind of beak shape, right? Kind of pointy. And the foods that they eat could be another rule that you have for membership in this category. We could have our example of the chickadee again. But maybe with some other kinds of birds as well. Like juncos, or a tufted titmouse. Kind of adorable little birds. But these all kind of fit that definition, and we have them in this category, right? Although, okay, right. It is possible to group items without understanding all the criteria used to group them. So you might have a category, but you couldn't actually verbalize all the exact rules for those categories. Okay? So if we think of our example there, with the small songbirds, they're small, they're beak-shaped, and what they eat seeds, right? Small beak, kind of pointy, also physically small. But think about those rules versus the actual category, small passerines. So if we have our little groups here that we've created, right, that you can think of, okay, well, a pigeon actually fits a lot of these rules. They're small, they have a similar beak shape, they eat similar food. So are they small passerines? No, we know that they're not. They're not songbirds. But it might be harder to list out all the rules, right? Sometimes exceptions might actually fit all the rules, but then they're not actually members of those categories. Another classic example is when you think of the category of birds, you're less likely to think of a penguin, or an ostrich, right? but they are in that category, actually. It's kind of the opposite problem. Okay. What about categories? What about animals creating categories, right? What about animals categorizing? How do we test for that? Oh yeah, this is showing it's actually separate. Okay, great. Okay, how do we test for that? You can set up experiments in the lab where you'll give an animal. Here they're showing a starling. It's definitely a starling, but they're talking about a zebrafinch experiment. I don't know what's going on there. But this is a starling. I'm pretty sure that's what it's supposed to be anyway. It's a bird. It's a bird. It's a bird. Here we have a bird in a kind of chamber. Right? And you train the animal when they have one stimulus to go to one side, go to one perch. And when they get a different stimulus, they go to the other perch. That's one way to set up a go, no-go experiment. And often there are little infrared sensors to tell when the birds have landed on the perches. Okay, so you can record what perch the bird landed on. And what you can do once you've trained animals, okay, when you hear this tone, go this way. When you hear that tone, go that way. You can present them with a new tone, right? And see where they categorize that. Do they go left or right? A tone is just one example of a stimulus. You can do this with all sorts of different things. You can also see, of course, if the animals can readily distinguish two things, right? That's the first step, I suppose. Can they actually tell when they hear this, they have to go here? When they hear A, they have to go left. When they hear B, they have to go right. Can they do that? Okay, that's step one. Now when I give them C, which way do they go? Which category do they group in? Right? So this is a way that we can see the categories that the animals make themselves. Right? How do they categorize information? So they had this kind of set up in an experiment with zebra finches. Okay. And they're playing them different kinds of notes from their own calls. Okay. So A, B, C, D notes. When we look at the figure, you can see that the different shapes correspond to different kinds of notes. Okay? So basically, they trained the animals to go to a certain perch when they hear a certain kind of note. And they can do that very well. And then, what you can do is give them novel exemplars and see what the animals do. So that's what they're doing here in all of these top lines. They're giving them new notes they weren't trained on. Okay? And they're still responding correctly. So basically, A note type groups were trained on A note, a set of A notes. To respond. Basically to peck more on a key. So here it's actually not going to perches, but that's one way you can do it. Here they're responding on a key. So they're trained when they hear A, peck the B. And you can see that they don't peck for B, C, and D as much, right? So training already happened. But here, they gave them new notes they hadn't heard before. So it's not that they're just memorizing all the notes that they heard. They're hearing new exemplars, new recordings of notes, and they're saying, oh yeah, that's A, or that's B, that's C, that's D, because that's what each of these different groups were trained on. These guys were previously trained on to respond to A notes. These ones were trained to respond to B notes, C, and D. And then here, when they're given novel exemplars that they hadn't heard before, they're still performing well. So all this is showing is, yeah, sure, the animals can categorize the notes into different groups, but it's not just that. They're not just memorizing the categorization. When they hear something they hadn't heard before, they're still responding as categorizing those notes. Does that make sense? Any questions on that? I kind of was talking in circles there. Yeah.
I'm not very musically inclined, so like hearing a note and then how do they categorize a new note?
So they're hearing, and don't even worry about music. So they're not like A musical notes. They're parts of the bird's actual call. Okay. So before you see these graphs even, they're given these 4 different kinds of notes, and they're basically rewarded with food when they hear one type. And there's 4 different groups, right? So these guys were rewarded when they heard A notes, these B, these C, these D. Okay? But they also heard all of the notes. And when they hear those other notes, they don't get food. Okay? And then when they gave them new notes they'd never heard before, they were still responding to them in the way that they categorized them as different.
Oh, so like if they thought it was not a B note, then they wouldn't stand on the thing.
Yeah, here it's actually not even standing on a perch, it's pecking at a key.
So they could tell it was not the correct note to get the food?
That's right.
Cool.
Yeah. Okay, great. Thank you. Other questions? Basically, this figure is just trying to show you the birds didn't just memorize a whole set of things they were just hearing. They actually are categorizing these things as different. So that's what the text there means. They were presented with novel exemplars. So new, novel, and it's just another item in that category. Okay. Right. So this is kind of summarizing this point that I'm trying to make. So animals can learn to respond to stimuli differently without forming categories, right? They might make those discriminations. Hear one tone, A, hear an A tone and a B tone. Yeah, they're different. But that doesn't necessarily mean, for sure, that they're forming categories. It means they're discriminating them. But when you give them a novel exemplar, so a tone they hadn't heard before that is still within the same category, that shows formation of the category. So there is some kind of evolutionary significance here, because concept formation exists in some form in every single species. Absolutely. Because there's adaptive value. Right? You need to know who is the predator, who is the prey. That's a category being formed, right? In a sense with predator and prey, and there's also a sense of approach and avoidance, right? You wouldn't want to approach a predator. So that's a pretty important thing to be able to categorize, to make a concept form. And then what ends up happening, right, instead of just memorizing every single individual, There's kind of a generalized learning. Let's say your predators are big cats, right? Like lions. It makes a lot of sense to kind of have a generalized concept. So when you see, I don't know, a panther, you don't think, I don't know what this is. Maybe it's food. No, there's a concept being formed there, right? There's generalized learning. What is true of one category member is applied to other category members without needing to learn it again. That makes a lot of sense. But you can think about it for prey as well. So here's a blue jay trying to eat a monarch butterfly, right? Makes them sick. Blah. Okay. I'm not going to eat those butterflies anymore. Right, there's adaptive value in creating concepts. Otherwise, this blue jay might eat lots and lots of poisonous butterflies. Right? Okay, but there are disadvantages of categorization. So you can form stereotypes. This works, of course, with people as well. Don't think I need to explain that to you guys. But not all members of a category are actually the same. So it's a good heuristic. It's a good rule to use in general. It's very helpful. It's adaptive. But it doesn't actually mean that all members of a category are exactly the same all the time, right? You guys know this. Everyone knows this. I hope. And it is possible to incorrectly classify an individual as belonging to a category when they don't actually belong to that category, and that can be a disadvantage. So in this example, with the blue jays getting sick from that monarch butterfly, when they see a viceroy butterfly, they might think, oh, I can't eat that either. Because it's got a lot of the same features, right? It's a butterfly, has kind of that same, has the same colors, kind of the same patterns, some of the same coloration, but it's actually not poisonous at all. It's perfectly delicious to eat. These butterflies, of course, they have an advantage there because of stereotypes, right? But the blue jay won't eat that either when he could have been. So there are some disadvantages to categorizing as well. Okay, different kinds of categorization. How do we categorize different themes? Well, one way is perceptual categorization. So this is using a sensory input from one modality to classify items. So you could think, these birds blue, these birds red. Different category, red birds and blue birds. Here we're using vision, color vision, to classify these items. But it could be auditory as well. It could be any kind of sensory modality. Okay. Okay, another kind of categorizing in the lab with animals is with something called stimulus generalization. So subjects are trained to respond to a particular stimulus and then tested to see if they respond to similar stimuli. And these tests measure the strength of responding. So strength of responding would be how many times the animal responds. And what you end up getting is a gradient of responses around the originally trained stimulus. Okay. What does that mean? Well, there's an example in your textbook. See that here. Okay, what we're looking at, rate of pecking. Okay, pecking is food, right? Okay, they're pecking something to get food. You can see them here. Here's the pigeon, pecking on this key. They were trained that their S plus will get food when they peck, when they hear a tone of 1,000 hertz. And the bottom here are the testing tones. So birds are trained, we're looking just at A for now. They're trained for 100 hertz. So when it's not 100 hertz, they don't get food. Okay. And then the testing tones, so the tones they test with, so they're presenting the animal with a bunch of different tones. Have a gradient here from 300 to 3600. So you can see that as the testing tone gets closer to 1,000, the responding goes up, and then it comes back down. Right? You can see that. Goes up, and then right when it hits 1,000, which is somewhere in here, right? It kind of peaks, and then it goes back down. Okay, makes sense. In B, they had training where 100 hertz was constantly played. That was actually not great for the pigeon. Didn't really increase its responding very much when presented with these different tones. This one isn't as interesting, B. But when you look at C, they were trained respond at 1,000 hertz, don't respond at 950 hertz. You can see this very narrow rate of responding, right around 1,000. And then they're not really responding at all with any of these other tones. Okay. So the idea here is that animals can be trained to respond to a smaller set of stimuli and create a narrower generalization gradient. So even if things seem broad at the beginning, you can train animals to become very specific with their discriminations. And humans, for example, we engage in discrimination training to obtain very narrow generalization gradients. What are some examples of that? You can learn, let's say you start learning birding. You might start out thinking, well, I know what a big bird is and a small bird is. But as you gain more experience, it becomes less and less effort to get very specific in what kind of birds you see, right? You might just be able to hear a bird and know, oh, I know what bird that is. Over time, even with birds that are hard for casual birders, you might get really good at it. Right? So this is something humans engage in a lot, where we can have very narrow generalization gradients. Okay. Just something to keep in note. Stimuli can often be correctly categorized without actually forming a category. So even if an animal can categorize things as two different, do we know if they form different categories? Don't always know that. for example, pigeons can learn categories for images with humans versus waters versus trees, so you're showing them different pictures. So you show them a bunch of different human faces, different bodies of water, different kinds of trees. But we know that they're actually using feature information, not actual concepts of human, water, and tree. Can't know that for sure. If they're forming concepts of human, water, and tree.